Hurricane Joaquin, packing winds of 130 miles an hour, continues to hammer the Bahamas as forecasters warn the Category 4 could next move up the U.S. East Coast. And even though forecasters also say Joaquin could begin to weaken on Saturday, residents from the Carolinas to Maine are on high alert. NASA scientists have developed a new 3D scan that can take us inside storms. And these 3D scans are providing powerful new data about Joaquin. Dalia Kirschenbaum, a NASA physical scientist, joins us now from NASA's Goddard Space Flight Center in Maryland to tell us more. Welcome, Dalia.
Thank you very much for having me.
So, Dalia, tell us how these 3D scans work exactly, and what can we learn about Hurricane Joaquin by examining it through them?
The Global Precipitation Measurement Mission, or GPM, Core Observatory was launched in February of 2014, and it has the most advanced instruments to measure precipitation from space. So what we're seeing here is a view of Joaquin as it was a tropical storm on September 29th. Now, what's amazing about the satellite is that it has a radar that can look three-dimensionally through the clouds layer by layer to see heavy rain from the reds and greens on the bottom and actually snow and ice expanding on top. So what's really interesting about this specific image is you see the precipitation, the snow kind of piling up on the eastern side of the storm. And that's really indicative of pretty strong winds, environmental winds, that are inhibiting this storm from getting stronger at that time.
So we are very late in hurricane season. Can this information from these scans also help us understand what's causing Hurricane Joaquin to intensify at this stage in the season?
That's right. By being able to have a three-dimensional profile of precipitation, and not only a three-dimensional profile, but actually a global picture, we're able to track these storms and the rain associated with them as they go through from formation all the way through and move up the East Coast. Now, this data is really important for forecasters, for example, the National Hurricane Center, to better understand the internal structure of the storm, how it might intensify, and where it might move.
Okay, so the East Coast...
So what you're seeing here...
Sorry, go ahead.
No, so what you're seeing here is this global view from the GPM, the Global Precipitation Measurement Network of satellites. So you can see rainfall in both the frontal systems associated with where we are now in the eastern region, as well as the information from rainfall in Hurricane Joaquin.
So what can you tell us about what else we can expect from looking at these images as Joaquin moves northward? I mean, we know the East Coast has already experienced heavy rainfall. Looking at these images right now, what can you tell us?
That's right. We already have a lot of rainfall in this area. And so by being able to look over time at rainfall accumulation, you're actually able to see where we have some pretty strong rainfall associated with these frontal systems in our area or in all along the eastern seaboard, as well as for Hurricane Joaquin. And so that tells us and emergency responders about where we might have more impacts, such as flooding and even landslides.
So how will emergency responders use this information?
Well, what's really interesting is that the GPM satellite can see individual storms, but the network altogether can give us this global picture about every 30 minutes. And that's a really unique information, especially in areas where ground-based radars don't extend, such as over the oceans or even in developing countries. So what's really important is to better understand the hurricane as this moves both from Africa all the way up the coast. And so GPM is giving us that global picture both in our backyards as well as around the world.
Certainly fascinating stuff. Where can people go to learn more?
Well, you can learn more at nasa.gov/GPM or /hurricane, and our Twitter hashtag is NASA_rain.
Dalia, thank you so much for that.
Thank you so much.